In a previous video, I showed how to complete the square through a conceptual argument, and in this video, we'll show it through a more formal argument. First, notice that if we square a binomial, we'll have x plus a squared is equal to x squared plus 2ax plus a squared. And we don't want like that 2a there. We want that to be a single letter, and you'll see why later. So let 2a be called b, then as a result, a is equal to b over 2. And we have this result. So that squared term becomes x squared plus bx plus b over 2 squared. And the advantage of this is look at the bx term. Is just one number there. And we know what we can add to that in order to have a square. Let's see how it works in practice. So we're going to have a general example and a specific example. And if you feel not so comfortable with this, I think you should look at the specific example first. The general example shows what we're doing at every step in letters, but if you're not feeling comfortable yet, you can ignore that for now. So the first step is to bring the constant term to the other side. So that means we're going to subtract the c from both sides in the general case and subtract -3 or add 3 to both sides of the specific case. So we have x squared plus 8x is equal to 3. Now notice we have an x squared term and an x term, and what do we need to do to make it like our example? Well, we need to add b over 2 squared to both sides. And in the first general case, we just do that in letters. And in the other case, well, what's b over 2 squared in this case? Well, the b is going to be 8. 8 over 2 squared is going to be 16. So we're going to add 16 to both sides, and we're going to get x squared plus 8x plus 16 is equal to 19. And because of what we did, we're now able to factor that as a product of two identical binomials. In other words, we have a square. So factor. And we do that in the general case. Trust me, I'm obeying the rules. And in the specific case, that becomes x plus 4 squared is equal to 19. Then it just becomes a matter of finding the square root of both sides. In this case, x plus 4 is equal to plus or minus 19. And then you just solve for x by getting rid of the remaining number on the left-hand side. So that becomes x is equal to minus 4 plus or minus 19. And so this is an algorithm. It will work in any situation as long as the number in the square root is going to be positive. Otherwise, it's called having imaginary roots. And it's worth saying that the general case is very, very similar to what you might already know or might later learn as the quadratic formula. The quadratic formula is in the case where there's ax squared plus bx plus c, and in this case, there's no a term. A is just equal to 1. And in fact, I could rearrange the formula here if I wanted to include that. So basically what our formula below is a version of the quadratic formula. And in fact, in mathematics, you often start with a concrete example, and then you use that to make a general case. So your intuition will lead to a basic method, and then you formalize it later once you have a more general case.